30 minutes to begin this live class. You don't.
It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle.
Hello,
When you pay the
welcome
price.
on board. I'm so happy to have you people on board. Today on this live stream, on this live session, we'll be handling just shots. So what we'll be doing is that we'll be solving past questions, not the usual way, not the step-by-step way, but we'll be using 5 seconds, 10 seconds to answer them in a using shortcuts. Yes, using shortcuts. In e-exams, at the e-center, time waits for no one. You've had an experience of it. And this is the final lap of Math 1-1 exams. Whatever you get in your exams is what you will see. Yes. So you have to pay close attention to these and then these tricks. Before we move into what we're going to be doing, I would love you to share these videos with your friends. Go right now. I'm going off for a short break so that you can share these videos to your departmental group, share it on your status, share it to your friends, invite them, because what we are doing here, this content will go a long way in rescuing someone from failure. Yep. We've had testimonies of how someone that carried over a course for about 3 years, 3 times Math 1-1, watched our YouTube videos, and he made mention of one exactly, which was a shortcut video on partial fraction, and because of that he was able to scale through. He did not fail again. So just imagine what this particular video will do to the life of someone. Just imagine what this particular video will do to the result of somebody. So don't hold it, don't keep it to yourself, do all to share.
It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1.
Okay, so we'll be starting off with limits. What are shortcuts in limits? Yeah, so we've done videos on limits, from limit by substitution to limit by factorization method and L'Hopital's rule. But then the shortcut I'm going to be telling you people is limit tending to infinity. So in case you did not understand all those ones, you could do well to watch out the videos. We've already done them on the channel. So limit to infinity, this is what it's all about. When you're given a question and let's say x tends to infinity, t tends to infinity of a particular function, you do not need to solve. The shortcut is look for where the highest power is. So the highest power of x is, so we come here, we see 2, we come here, we see the power is 2, we come here, we see the power is 7. So the highest power is at the numerator. If the highest power is at the numerator, your answer is what? Infinity. So in scenarios where you find out, okay, let's say we have 3x squared plus 4x minus 5 over 7x raised to the power of 4 minus 3x plus 4. So in a scenario where we have this lim as x tends to infinity, we look for where the highest power is once again. So we see we have 2, we have 1, we have 1 here, and then we have 4. We discovered that the highest power is situated at the denominator. If the highest power is situated at the denominator, our answer is 0. You see, we do not need to solve. And then let's move in a case where we have limit as x tends to infinity. limit as x tends to infinity, if I have it 5x squared minus 3x plus 4 over 3x squared minus 4x minus 7. So we find out that what's the highest power? We have 2 here. We also have 1 here. We have 1 here. We have 2. We find out that the highest power, they are recurrent both in first in at the numerator and at the denominator. In a case like this, we just pick out the coefficient of the um, variable, which will give us what? 5 over 3. So this becomes our answer. There's no need to solve. You just look out for where the highest power is. If it's at the numerator, the answer is what? Infinity. If it's at the denominator, the answer is 0. And if the powers are the same, you have the highest power is also the same with the highest power in the denominator. You just pick out the coefficient of x squared. So I'm sure we get this right. We're moving over to shortcut on differentiation. Yes, shortcut on differentiation. So let's go for a short break and I'll be right back.
It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price on Math 1-1, and that's why he's confident about his victory.
So welcome back from the short break. We'll be moving down to differentiation. Now, this we're moving to a more critical stage. Yes, a more critical topic. We have a lot of shortcuts on that differentiation. So I will love you this time. I'll slow down and I will love you to pay keen attention. If you are yet to invite your friends, please do so. And I want you to tell us what department you are from in the comment section. Tell us your institution, your department. If you are from Bingham University, if you are from Harvard, tell us you're from Harvard, and then tell us your department. If you are from physics, in the comment section. So let's move to differentiation. Let's answer some questions under that. I think I have past questions here. So we have this question. Find the derivative. You have y equal to 4x minus 3 raised power 5. I'm told to find the first we're told to find the first derivative, yes, of this particular function. So now, normally, we're going to use the function or function rule, but I'm telling you, these exams, you don't have time to waste. So let me tell you, this is a shortcut. So this is my answer. How did I get this? I'm going to explain to you. So in a case like this, function of function, you say you do it like a normal differentiation. 5 times 1, what's the coefficient here? 1 bar. 5 times 1, you have what? 5. Yeah, thank you. I have some people with me. Yeah, so 5 times 1, 5. Then you bring this, put this out, you have what? 4x minus 3. So, and then the next thing you do is to multiply by the derivative of whatever you have in the bracket. So 4x minus 3 differentiated, you'll be left with what? 4. Hmm. Please, I want you to commend my the students at the background. They are serious students. Yeah, they're just giving me answers. So we have 5 times 4 to be equal to what? 20. Don't forget we have raised power 4 here. 5 times 1, 5. Then we have this 5 minus 1, 4, right? Times 4. So we have 20 in bracket 4x minus 3 raised power 4. This becomes our answer. So you don't need to cram these things. It's just like the normal differentiation, you know. You know, when you have y is equal to 3x squared, what do? You say 2 times 3 is what? That's y prime. 6, right? You now say x. 2 minus 1 is what? 1, right? So that's the same thing you're doing here. You say 5 times the coefficient gives us 5. You put this as your x, as you put this as your x. So we have 5 times 1 gives us 5. We assume this is to be our x, assume this to be our x. Then what do we do to this power here? We remove 1 from this, it gives us 1. So we remove 1 from 5, it gives us 4. But then we are multiplying by what? The different, the derivative of what is in the bracket. It gives us 4. We multiply. Now, this is what happens. We differentiate x, it gives us what? 1. 6 times 1 still remains 1. So this is the part that is hidden that you don't know. So I'm sure we are getting it, right? This will go a long way. You saw how I solved it under seconds. This will go a long way in helping you out. So let's move to another question. Please, I would love you to be so much engaged. So in the comment section, if you like a particular shortcut, tell me I like it. Yes, and if you are here to invite your friends, do well to invite them. I'm enjoying this already. So let's move to another question. Um, the question it looks like this, Sha. It looks like the same question. So we have if y is equal to x cube sine 5x. Okay, this is a different question. Yes. Now, looking at this, we are applying product rule because you have a function here multiplying another function here, right? So product rule. But instead of using the long product rule, where you're doing u dv over dx plus v du over dx, that is that's a long method. So I'll be showing you how to solve this as quick as possible, and I'll be having my y prime. This is dy dx. Don't get confused. As this. So now this is what I did. I kept this constant, right? If you keep this constant, you'll be having what x cubed. Leave this constant, right? I now differentiated this. Differentiate sine 5x, you'll be having what? Cos 5 cos 5x. You'll be having 5 cos 5x. So when I multiplied, 5 came here, right? I shall have 5x cubed cos 5x. Then I now did plus. Now, you know I kept this constant before and differentiated this. I'm now switched around. So I'm going to differentiate this. I have what? 3x squared. Then keep this constant. I'll be having what? Sin 5x. And this is my answer. See, things are not difficult if you know what to do. Okay, let's move to the next question. If you have any question, please leave it in the comment section. So yes, we have y, if y equal to cos in bracket 7x plus 2, find the y dx, which is y prime. So now, if I'm to do this is what I'll get. Sorry, hope you can see. Now, maybe you're wondering how did I get this as quickly as possible. See, it's possible for you to be solving like this in e-center. How long did it take me to solve this thing? So, yeah, 5 seconds. So, let me show you the way around it. This is function of function, right? But instead of using that long method, what you do is when you differentiate cos x, what do you have? Minus sine x, right? You have minus sine x. So let's assume this to be our x. So we'll be having minus sine 7x plus 2. Then that's not all. Remember what we did in the previous function of function. We differentiated what we had in the bracket. It gave us what? 7. Right? It gave us 7. So multiply by what? 7. We'll be left with what? Minus 7 sine 7x plus 2. So now, this is how to go about it. Function of function, you can use this this shortcut for function of function. This particular one, you can use it for product rule. So now let's move to another question. If you are liking this, say I like this in the comment section. Yes. You see, maths is not difficult, though. It's not difficult. And then, truly and sincerely, my wish and my desire is that each and every one of you watching this video come out excellently in Math 121. And please, when the result comes out, I would love you to give reviews. Yep. I love you to give testimonies because I know this particular video is going to help a lot of persons. So let's move to the next one. Okay, we're getting deeper. We are told to differentiate this exponential sine 2x. So now, given y equal to this, find y prime, which is the derivative of this. So differentiating exponentials, what we do is my answer becomes what? So don't think I'm cramming this answer. I'm looking at it and I'm solving it. That's how you can do too. So how did I get it? For if you are differentiating exponential, your answer will write exponential everything. Write the question. Write it as it is exponential sine 2x. But then you're not done. What do you need to add? Differentiate what is on top. Differentiate sine 2x. You have what? 2 cos 2x. This becomes your what? Answer. Yeah, so it's I'm sure it's getting interesting. Let's move on. Let's move on. Okay, before we go on, I think we solved something like this. I want you to try something else. So you have 15 seconds for this. 15 seconds. If y is equal to cos in bracket 2x plus 5, differentiate and give me your answer. So we'll go on a short break. You have 15 seconds. So, wow, that's nice. That's a good response from you people. So, let's move on to another question. We have now, let's solve a question involving ln. If y equal to these are just basic differentiation. Yeah, ln x squared. I told to differentiate this. So, y prime will what? Will equal to. So, this is actually the wrong way. But then let me show you how I got to get 2 over x. So now, and then when you have y is equal to ln x cubed, you'll be having what? 3 over x. When you have y equal to ln, when you have y equal to, thank you, ln x raised to power 5, you're having what? 5 over x. So it's a shortcut. When you see ln question, you just close one eye and tick. So how do you go about that? Ln x. When you have ln x, you do 1 over that particular thing. So we have 1 over x squared, right? We have ln x squared. So 1 over x squared. Then times, differentiate this. What do? It gives you 2x. So x cancel what? 1x. You'll be left with what? 2 over x. But instead of going through all this struggle here, this is just the short method. You have ln x cubed. The answer is what? 3 over x. So let's move further. If you're enjoying this, say I am enjoying this on comment section. Are you guys seeing how this is stress free? This is how people enter exam hall and they get 39, they get 40. So let's move. Let's move. Okay, so now we're moving to quotient. If y equal to sine 2x over 2x plus 5, we're asked to find y prime. So now how are we going to do this? Let me show you how I do it. Okay, so this is what I'll be having. Then if I choose to open it up, I'll be having 4 sine 2x plus 4x plus 10 cos 2x. Yep. Okay, so this is what happened. Instead of using the normal one, v du over dx minus u dv over dx over v squared. Um, over x 2x plus 5. Okay, you can't see it very well. Okay, okay. So this is what happened. This is my v and this is my u. This can we go on a short break? Sorry, I have some technical issues. Sorry, I know that might be so confusing. So let me take it once again. Now, you might be saying product rule, function of function. How is it that we get shortcut? It's just like an application of the formula, but in a more smarter way. So we're actually applying this formula, but then in a more smarter way. So what we do, we have our u to be this and our v to be this. So we do not need that for now. Yes. So what you just do, you write out your v, you write out the denominator. Yes, y prime is equal to what? 2x plus 5. You differentiate this. It gives us what? Minus. It gives us 2 cos 2x. So now we have minus. Now, since we kept this constant, we're going to do the reverse process. We'll keep sine 2x constant, and then we differentiate this, and we'll be having what? 2 over what? The square of this, 2x plus 5 all squared. And this becomes our answer. Yep. So let's see more questions on that. Let's see more questions on differentiation. So now we have this question. It's kind of a product rule. If y is equal to x raised to power 5 exponential x, how do we find y prime prime? Y prime, sorry. For us to get y prime, this is product rule. And it means we keep this constant, differentiate this. Remember, when you differentiate exponential x, you have what? Exponential x. And then plus what? Differentiate this, you have what? 5x exponential x. So this becomes our answer. So when you have good students, um, your work will be made much more interesting and less burdensome. So I really want to appreciate people that are at the back of the camera, no, in front of the camera. Yes, well done. Yes, and I also want to use the medium to appreciate my media um, crew. Yes, they're really putting a whole lot of effort to make this this live streaming go well. So let's move on to another one. I know you may be saying there are a whole lot of questions that are doing here. Hmm. This one is small. We'll be going into when we enter integration. You'll be able to appreciate the shortcuts. Let me leave it for there. Let me not give you a whole lot of gist now. So now we have okay, find derivative of if y equal to root x plus 1 over root x minus 3. So I was looking at this question now, saying, can there really be a shortcut? If you are giving square root of something, I found it out. You know the normal way. Let's go through the normal way. The normal way, we say we can rewrite this to be what? X raised power what? 1 over 2 plus what? X raised power minus 1 over 2, right? Minus 3. When I say dy over dx is equal to this multiplied by this, you have 1 over 2, right? X minus 3 over 2, right? So now, minus 1 over 2. When you remove 1 from this, it becomes minus 1 over 2. So plus, when you multiply this one, it changes to minus, right? Minus 1 over 2 x. When you remove 1, it becomes what? Minus 3 over 2. And when you differentiate this, it leaves. So solving further, this is how you're going to solve for a exam if you're following normal step. But I'm going to show you the shortcut. This you'll be having 1 over what? 2 root what? X minus 1 over 2 root x cubed. So now, this is the long process you need to take. But now, I've been able to sit down with it and then I've been able to carve out, sorry for that noise. I've been able to sit down with it and I'll be able to carve out a shortcut. Right from here, when you are differentiating anything in square roots, your answer is always 1 over 2 root of that particular thing. We are going to solve, I think I will look for a question that relates to this. We're going to solve it very soon. There's another question where we don't just have x, maybe we have something another function inside. When you are differentiating root x, your answer is 1 over 2 root what? X. Root whatever is in this. And when you are differentiating 1 over root x, your answer is always minus 1 over 2, the function raised power of 3. Yes. So let's try and solve one question. Let's try and solve one question. Let me look for a question regarding that. Remember, when you differentiate the root of a function, you get 1 over 2 square root of that particular function. Is that clear? So let's check for The question, okay, I've seen one. So let's come over here. We have if y is equal to square root of x minus 1. Instead of you doing the whole work of this, the answer is what? 1 y prime 1 over 2 root x minus 1. Now, which one is easier? Which one is easier? Going through this whole stress or just having your answer? How many seconds did it take me to answer this? So these are basic tricks that you need to know and master that will give you an edge in your E exam. Whenever you have the square root of any function, your answer is 1 over 2 root of that particular function. So I guess is there any other question? Is there any other question regarding that? Just to solidify um, our knowledge on this. Okay, I'm not seeing anyone. But in case you see, you solve. So please just stay with me until the end because we'll be doing integration. We'll be doing integration. You don't want to miss out shortcut on integration by parts. I don't know if you solved any integration by parts question. You know that the part is long. Okay, let's clean this. Okay, let's see. Is there any more question? Okay, so now I guess before we've touched product shortcuts, we've touched function shortcuts, we've also touched okay, we've also touched quotient and the rest, exponential shortcuts. So we'll be moving over to implicit. Now, let's go on a short break and then right back.
It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically walk into victory. This is Daniel. He has paid the price for Math 1-1, and that's why he's confident about his victory. It's a principle. When you pay the price, you automatically.
Okay, yep. So let's go on. Implicit differentiation. The shortcut is whenever you have a let's pick a question. We have no, I don't want a simple question. Let's look at something complex. Can I get a difficult question? Ooh, okay. It's not really difficult, but let's solve this. X squared minus xy plus y squared equal to 7. So if I have this implicit means having both x and y, right? It's having um, different functions in a particular equation. So how do we solve this? What we need to do is differentiate with respect to, we have minus, differentiate with respect to x. So we have x here, differentiate x squared with respect to x, we'll be having what? 2x. We have the x here, differentiate minus x, we'll be having what? Minus 1. Minus 1 times y gives us minus y. We do not have x here, so let's leave it. Forget about this 7. It's nothing. So over, now differentiate with respect to y. Is there y here? No. Forget about it. Is that why here? You so you'll be having what? Minus x, right? Is that why here? We'll be having what? Plus 2y. So our final answer will be what? Minus in bracket 2x minus y over, if you factor out minus, what do we have? Minus in bracket x minus 2y. Minus cancel minus, we have our final answer y prime to be equal to, sorry, we have our final answer, that's the y over the x to be equal to 2x minus y over x minus 2y. So there's no need for stress. What you just need to do is this upper one, you differentiate with respect to x, but mind you, you're multiplying by minus at the end of the day. So you have 2x, this one you have minus y, multiply through by minus and the rest. So that's it for implicit. Let me give us 15 seconds to solve this simple one. I've not been able to find difficult implicit questions, but let me just give us this so that we'll be able to practice. You have x squared plus y squared plus 3x squared y equal to 19. You're told to find different do implicit differentiation for this. So you have the next 15 seconds. Who will make me proud? I'm watching out for you. Yeah, so welcome back. We've been able to, I'm sure we've gotten our answers. We've been able to do a whole lot of questions and shortcuts on limit of function and then on differentiation. We'll be moving over to integration, but that'll be in another live stream. So get ready for that. Get ready for that. We don't want to bulk you a whole lot of materials to consume at once. We'll be doing that shortly from now. So have a nice day. If you are here to share this video, you are wrong. So unwrong yourself, yes, undo your faults by sharing these videos out, and then make sure you subscribe if you know you got value. One way of encouraging us is by subscribing, is by liking and sharing to your friends. Yes, to encourage us. This thing we're doing is free. Yes, because we want to impact you. We don't want failures around. We know that what we are doing is having a long way to help someone out there pass Math 101 exams. So share this video. Thank you very much. See you in the next live stream.